Guys, my name is Simran, and I am an outreach volunteer for Flight Crowd. And I first met Finley when I was invited to a safe landing vision assembly. And I really enjoyed the day. I learned about a whole different perspective to aviation, something that's really important. And essentially, safe landing is all about the environment and creating sustainable aviation. So Finley over here is an aerospace engineer with a background in aircraft engine design. He's worked in system design at Rolls-Royce for engines on various Airbus and Boeing aircraft, both in service and future concepts. He's now the co-founder and think tank lead at Safe Landing, a global community of aviation workers and enthusiasts who care about the future of our industry and planet. And I'll hand it over to Finley, who will be leading the PowerPoint. So, Finley, it's over to you now.
Thank you, Simran. Hey, everybody. So yeah, I'm Finlay. I'm at Safe Landing, and I'm gonna talk to you for about half an hour about sustainable aviation, and then hopefully we'll have plenty of time for Q&A. I am good at talking for a long time though, so I'll try and keep myself short and make sure you guys can ask lots of questions. But also feel free, put up your hand, or feel free just to unmute yourself whenever and shout out a question as I'm going through. Very happy to take questions and answer stuff as I go along. So I'll start off with a little background to myself. As I say, a co-founder of Safe Landing. I'll get in a bit into what our organization is about. My background is I studied mechanical engineering and then I went into the aerospace industry, and specifically I was working at Rolls-Royce in Derby and Bristol and Singapore. And I was mostly working in system design, looking at future aircraft engine design, some in service. I've worked on engines for Airbus A350 and A330 Neo, which are flying around. Um, but also I've spent most of my career working on future technologies, looking at the future engine systems that might go into future aircraft. So when I started my career, one of the first projects I worked on, just to give you a bit of a flavor of that, was the first composite fan blade engine, so carbon fiber fan blade engine that Rolls-Royce ran. Um, the fan blades are the blades that you can see in the front of the engine. Conventionally, they're titanium, so they're metal, and you can see that on the other three engines. And you can see the blue one, that's the carbon fiber, is a lot bigger. This is because we're making engines bigger in diameter all the time to give them better propulsive efficiency. But as you do that, the engine gets heavier, and that creates drag, and it means you burn more fuel. So you try and make your structures lighter, and that's part of the reason why we're going to carbon fiber. Um, Moving on, actually, yeah, that's me looking a little bit younger, standing in front of that first carbon fiber engine. But just to give you a scale of the size of the engine, I mean, it would be the size of the ceiling in my room here. They're pretty massive. So really large engines for the long haul aircraft that would fly for, 10, 15 hours. Um, I've worked quite a lot on the UltraFan project, which is a future engine. It has carbon fiber blades, but also has a gearbox, which means the fan can spin really slow and can be
Um,
larger.
Sorry, hold on. I don't think the others can see the screen.
Oh, right, yeah. Can you let me just
Hold on. I can, but the others can't.
yeah, let's just go to try and reshare. How's that now? There's sorry, I couldn't see the chat, so I wasn't sure if people had.
No,
Let's
don't
see.
worry. Uh,
Let us
no,
know.
I can't see it now.
Try and change. Hmm. Uh, I've got a message that says your shared screen can be seen only by host and co-host. Um, And I don't.
Now,
Well,
yeah,
now, guys, sorry
yeah.
about that. It must have been me. Apologies, all.
That's all right. Would you like me to start again for the recording?
I think I think we're fine. I think we'll be all right, Finley.
Yeah.
You
Yeah, just continue.
can just
Sorry.
cut that bit because you're
Yeah.
probably recording it and you could see it. So how about I go to there and I'll go here and I'll start from here.
Perfect. Thank you.
So UltraFan engine, it's a future engine design that's not entered service yet. So this is the sort of thing we might see in the 2030s. The engine is even bigger. It's got a gearbox that means the turbine that's in the back can spin really fast. The big fan at the front can spin really slow. And you can see like how much bigger these engines are getting compared to the engines that have been around for the last 30, 40 years. So yes, that's the sort of thing I was working on. And I worked in something called future programs. So the way this works, Airbus or Boeing are the big airframe manufacturers. They design like a future aircraft concept and they come to the engine manufacturers like Rolls-Royce, but also there's General Electric, Pratt and Whitney, Safran are the other engine manufacturers, and they'd get them to compete to create engine concepts to go with the aircraft. And they'd be aiming for efficiency improvements, and a lot of those efficiency improvements come from the engines, um, as well as the more aerodynamic wings and that kind of thing. So the sort of concepts I was working on, as I say, UltraFan, there's this power gearbox that means the turbine that's yellow at the back can spin really fast, and the fan can spin slow, and that means that it moves efficiently. Um, the next level of I also worked on like even sort of more futuristic technology. So this is a variable pitch fan, as those fan blades at the front can change pitch, they're not fixed pitch, and that means you can basically optimize the fan performance for different phases of the flight. So takeoff, cruise, climb, descent. And you can also do reverse thrust with it. But these are really complex, um, very complex and quite radical systems. And I, to be honest, began to get a bit frustrated that we weren't actually working on this technology as quickly as we needed to be, given we were in a climate emergency. We need to rapidly reduce emissions, and we really need this technology. So around about 2018, governments around the world declared a climate emergency. Everyone was talking about climate and emissions reductions a lot more. Um, we had things like Greta Thunberg, who's a climate campaigner, sailing across the Atlantic rather than flying to make a point. And the industry, I think, felt quite like this could be an issue for us. There was quite a lot of articles around should we be flying as much as we are? If we're in a climate crisis, can we justify it? So they came out with a sustainability strategy as an industry, and my company was quite significant in terms of developing that strategy. And it basically said, like, there's a bunch of technology that's coming along. You don't need to worry about things. You don't need to regulate us. We've got it in hand. And I looked at that strategy and I thought, I actually disagree with a lot of that. I'm working on this technology. I know it's what's possible, the reality of it, how far away it is. Um, and I thought, well, actually, the future, like the way the industry changes, it becoming sustainable is super important to whether this company succeeds in the future, whether the industry succeeds, whether I still have a job. So I think it's really important that employees question their leadership. Um, and if there's real concerns with the sustainability strategy, ask those questions. So I started this employee sustainability group and I was running it for a couple of years before I left in 2020. Uh, and so since then, the past 5 years, I really wanted to just get into environmental campaigning, but I realized that something that's missing in the debate is often there's sort of environmentalists on one side and there's industry on another, and it's quite us versus them. Environmentalists just want rapid climate action. The industry wants maximum profits. And often we just continue to expand our airports and our airlines, and we say, oh, it's because it's going to deliver these jobs, it's going to deliver this economic growth. So, one thing that's kind of obvious was that actually we need to be making the positive economic and the positive jobs argument about actually moving rapidly on decarbonisation. And having aviation workers, of which I am one, but I met a bunch of other pilots, air traffic controllers that all care about sustainability, we wanted to be spokespeople for a lot faster on environmental issues in aviation. So we formed Safe Landing, which is a group for aviation workers who want a sustainable future for the industry. Um, as I say, yeah, we've got a bunch of pilots, cabin crew. I'm an engineer, and we're a global community of aviation workers, students, and enthusiasts who care about the future of our industry and our planet. And we don't think that we need to prioritize one over the other. So anyone anywhere in the world connected to the industry, whether you're a worker or a student, or you're just enthusiastic about flying, you're very welcome to join the group. Um, our vision is that we want to live in a world where aviation can flourish in harmony with nature and the beauty of flying can be enjoyed by all for generations to come. So we're not anti-aviation, we're not just like pro the climate. We want aviation to thrive in the future, and we think that it's really important what we do today, being able to, fly in 20 years' time, be able to visit some of the tourist destinations that we love today. That will only be possible if we take sustainability seriously. Um, our mission, so yeah, we want to bring together that community, but also provide platforms that can harness our expertise. So as workers, we have a really in-depth understanding of our industry. We're best placed to design the future of it. And we really want to get everybody in our community to be able to contribute to creating and championing sustainable visions of the future of air travel for the benefit of everybody. Yeah, and just got a very different pictures up here, different trips we've done and advocacy days that we've been along to. So why do we think we need the group? Well, this is CO2 emissions from aviation over the past 80 years. And you can see that, we've been developing a lot of technology, like the stuff I was showing you earlier. But this is the trend of carbon emissions. It's on this upward trajectory and it's basically accelerating. We've had a dip due to COVID, but we're back on that CO2 emissions growth trajectory. So our group is saying this is a dangerous trajectory to be on. We need to set a new flight path. So I'm going to just talk you through, I think, 5 or so big questions about aviation's future and give you a sort of relatively quick answer to it. First question is, how big is aviation's impact? Because often our industry plays that down quite a lot. The next one is, how much time do we have? Do we have until 2050, 2060, or maybe do we need to act in the next 5, 10 years? What role will technology play? Will technology save us? How must aviation change and transform? What policies will get us there? And who's going to pay for this transition? So let's just go with the first one. How big is aviation's impact? So what the industry says, you guys might have heard this one before, aviation is only responsible for 2 or 3% of global CO2 emissions. So, if you put that in a pie chart like that, it looks just like a tiny little slither. What is the point of focusing on aviation, focus on road transport, heating, industry, other things instead? And this is quite an effective distraction technique. The thing is, UK emissions are 1% of global CO2 emissions. Same with like the emissions of Mexico or Germany. So 3% is actually huge. It's bigger than most countries. So if aviation was a country, it would be the 7th largest country in the world by emissions. The other thing is, in the UK, I'm in the UK just now, we already fly a lot more than the global average. So here already accounts for 8% of CO2. The other thing is that road transport, domestic heating, heavy industry, they all have routes to decarbonisation, electric cars, renewable energy. Aviation doesn't have that. So other sectors, the emissions will reduce, should be reducing over the next decade, but aviation's continuing to grow. So by 2040, aviation is projected to be the largest emitting sector in the UK. And then this also doesn't account for non-CO2 emissions. So things like contrail warming that effectively double or maybe even triple the impact of aviation. So even though, we're 8% of CO2, we're maybe 15% of total warming in terms of UK emissions. So summary of this really is that aviation's impact is significant, particularly given relatively few people fly. It's got a very outsized impact, and it's going to become like the biggest emitting sector that we need to do something about very quickly. So how much time do we have? Well, often um, we talk about 2050, and our industry has this net zero by 2050 targets that are apparently ambitious. They show us getting to zero CO2 in 2050. The reality, though, is that in order to limit ourselves in global warming to 2 degrees and as close to 1.5 degrees as possible, like we've signed up to in the Paris Agreement, the pathway between now and 2050 is really important. And you need to make massive cuts in the short term in order to give yourself any chance. On our current pathway, we're going to go past 1.5 degrees, possibly already, certainly in the next few years, and we're going to go through 2 degrees C before 2040. A decade before we get to 2050, everything could essentially be over, and we'll be into runaway global warming, that could be very dangerous. So this is quite a nice little illustration of this. It's a hourglass timer, but what it's going to show is that since sort of 200 years ago, we've been gradually filling up the atmosphere, burning fossil fuels, filling up the atmosphere with carbon, and we've been accelerating that. We burn more and more fossil fuels every year. And the carbon budget for 1.5 degrees C has been running out more and more rapidly. This was in 2023. For a 50% chance of 1.5, we've got 7 years left. That was 3 years ago. So as I say, we've got sort of 3 or 4 years, certainly before 2030, where we think we're going to blow the budget. So really, the next 5, 10 years are absolutely vital. So will technology save us? Often the industry says, so we've got a mixture, we've got more efficient aircraft, we've got new zero carbon aircraft, we've got sustainable aviation fuel, carbon capture technology, all of this will fix the problem. However, I can tell you that it takes 10 or 15 years to design and develop and certify a new aircraft. Also, that there's real issues with zero carbon aircraft in terms of the size of them, how far they can fly in the near future. Well, sustainable aviation fuel is really resource intensive. We're really struggling to scale it up beyond like 1-2% of fuel at the moment. So unfortunately, there's no technology or fuel that can be scaled in the time required to decarbonize, in the next 10 years. While some technology and fuels will be useful and should be developed as quickly as we can, we will also need to fly differently and change our behavior. Just going to talk you through a couple of these technologies. So the first one is electric flight. So this is batteries powering an electric motor, powering a propeller. This is Viridian. They're doing a 9-seat aircraft that can probably fly maybe 700, 800 kilometers. So, most modern aircraft, they have 200, 300 passengers. They can fly for many, many thousands of kilometers. So this will be a very different way of flying, more sort of point to point. Regional flights, you won't be able to fly across the Atlantic in this. So the reason why you're limited to small aircraft is the weight of batteries. Batteries are about, in terms of the energy, for the same amount of energy, you've got a kilogram of fuel. Firstly, you need about 50 kilogram batteries. Electric motors are more efficient than combustion engines. So that means that it's reduced a little bit, but you're still 25 times worse than fuel in terms of the energy stored. So you have to carry 25 times the mass for the same amount of energy. The other problem is when you burn jet fuel, it burns off and it disappears and your aircraft gets lighter. Batteries discharge, they don't get lighter as you fly, and that's like a double whammy. So This means that it will only be viable for small aircraft flying relatively short distances for the time being, and it won't decarbonize conventional air travel. The flights that are taking off from Heathrow and flying around the world. It might be able to get you from Dublin to Liverpool, or from Glasgow to Belfast, or from London across to Amsterdam, but you won't be able to go much further than that. Hydrogen flight. Hydrogen is doesn't have issues with weight, but it's got issues with volume. So you need a lot more space to fill your hydrogen in. Um, but yes, the reason is you need about 4 times the volume of jet fuel to store the same amount of energy. So 1 liter of jet fuel becomes 4 liters of liquid hydrogen. Hydrogen is also really difficult to store. If you liquefy it to get it down to a smaller volume, you need to cool it to minus 250 degrees C. So you're in this really complex storage tank that's cylindrical and it's got insulated walls. And you can't fit it in the wings like you can fit jet fuel in the wings of normal aircraft. And that means you need to put it in the fuselage. And that means you need a completely redesigned aircraft, which means um, just from a redesigning an aircraft point of view, you're then looking at probably 20 years to do that. So firstly, yeah, it requires very different redesigned aircraft and airports because you need all of the fueling infrastructure. Probably it will take 15, 20 years to develop and certify the first large aircraft. Airbus recently pushed their timelines back by 10 years. They're looking at kind of 2045, and that's for the first aircraft. And it also requires huge amounts of energy for the fuel, like very, very significant amount of energy, and it'll make it very expensive. So, yeah, basically liquid hydrogen potentially in the long run, but we're not going to be able to do anything the next decade. If you then look at biofuels, um, the problem with biofuels is the land required to grow enough biomass. So this study shows that in the UK, we need half of all the farmland in the UK for UK jet fuel demand today without any growth. Globally, you need like the whole of India or the whole of America, which are the two biggest agricultural countries in the world. So this quickly gives you issues with biodiversity loss, land use emissions that mean that biofuels are often actually worse than fossil fuels because of the knock-on effects they have to deforestation. Um, there is some pathways that are looking at biomass waste from like farms, food, that kind of thing, but that's at a much smaller scale, and we could probably only get to 5-10% of a jet fuel demand for that. So you then say, well, maybe rather than use biomass, we use electrofuels. So electrofuels um, take renewable energy and they turn it into jet fuel. Problem with this is the amount of energy that's required for that. So if you do a calculation, current UK aviation fuel demand, if you created it all with e-fuel, it would take 300 terawatt hours of energy, which didn't mean much to me. But if you then compare that to the UK grid generation in a year, it's basically the entire grid generation. Now, the green is wind energy, the blue is hydropower, and the orange is nuclear, and then the grey is fossil fuels. And obviously, half our grid today is fossil fuels. So you'd need the entire grid, which is half fossil fuels, or you'd need 3 times our renewables, or 4 times our wind generation, or 5 times our nuclear generation. So we need to build 5 times the amount of nuclear power stations we have today to produce this. So it just gives you an idea of the scale that's required to get there, and being able to do that, building 5 times our nuclear generation capacity or 4 times our wind generation will take decades. So this is just some of the reality behind the scale here. We're also not actually doing this. So we're not actually taxing aviation and building this stuff right now. So we need to change. How must aviation evolve? So our industry is saying we don't need to change. We can just continue as we are. And in fact, we're going to double in size. We're going to double air traffic over the next 15 years. Existing aircraft and the same type of airports. However, we know, as I just showed you, it's impossible to decarbonize if we continue to grow at that rate. Um, but slower, smarter, more efficient travel could create more jobs and improve our access to air travel and create a fairer system for all of us. But it will mean flying differently. So, how can we do that? So, we need to optimize for minimum. You saw how much energy it would take to create that jet fuel, whether it's biomass or e-fuel. So, we really need to optimize for minimum energy use. We'll likely fly less far and less fast. And obviously, if you fly less frequently as well, that helps. Some examples, if you have a fixed wing aircraft like this, rather than electrical vertical takeoff and landing, that's more efficient. If you have a slow propeller aircraft rather than a fast private jet, that's more efficient. And hybrid electric power is a way of getting some of the benefits of electric flight, but also having some of the range provided by jet fuel. You reduce emissions, you burn some jet fuel still, but you can burn a lot less. So that's something we're really excited by. And just to give you an idea of like electric aircraft development today, currently fully battery electric, there's only a two-seater trainer aircraft that can fly and flying 100 kilometers, which isn't very far, flying around for like half an hour kind of thing. Um, the next couple of years, we should then see four-seat, so room for some passengers, but only 200 kilometers, so flying like London to Birmingham. 2030, Viridian, the aircraft that I showed you, the nine-seat aircraft, that battery electric, and it could fly 500 kilometers by 2030, which is like London to Edinburgh or London to Dublin kind of thing. Mid 2030s, we'll then start to see like a 30-seater, but still only 200 kilometers if it's battery electric, but 800 kilometers, so we can go across to Europe, that kind of thing, if it's hybrid. And then 2035, Elysian is a Dutch company. They're looking at a 90-seater that is 800 kilometers electric and about 2,000 kilometers hybrid. So you can start to get across Europe in that type of aircraft, and it can carry a bit more people. So in about, the next 5, 10 years time, we will start to see this, but we will need to fly quite differently. They're much smaller aircraft. They don't fly as far and they won't fly as quickly. Um, but I think we'll start to see a bit of a regional network of these aircraft pop up that is more like local regional airports that are a lot smaller, and you go closer to where you live to closer to where you go, and it's relatively cheap because battery electric isn't that complicated, few moving parts, easy to maintain, and it's very similar technology to like electric cars and that kind of thing. If you think about it, this sort of network of slower flying, smaller aircraft, it will create this more distributed air travel network. But actually, lots of smaller aircraft and longer flight times means more work for aviation workers per passenger kilometer. We'll also maybe improve access to air travel because, at the moment, if I fly somewhere, I probably need to go to London or go to Glasgow or Edinburgh. So if you don't live close to one of these concentrated hubs, you have to travel quite far. And also countries, particularly in Central America, Africa, and some of the island countries in Southeast Asia, this could actually improve access to air travel for people that live there that don't have the most developed air transport network at the moment, whereas this could be more accessible, particularly where there's more renewable energy and energy is cheaper. We're also really excited about actually regulating private jets more and using the airports that private jets currently use to be the initial backbone of an electric flight network. For long range flights, we won't be able to do batteries for the time being. This is a blended wing body aircraft, so the rather than a tube and wing conventional aircraft, the fuselage is a wing itself, and that means that the whole thing generates lift, and this is really efficient. You can also put the engines on top of the fuselage, and that blocks ground noise for communities under the aircraft during takeoff and landing. Um, there's also something called the open rotor engine, which gets rid of the nacelle, the cover that goes around the engine, which is getting really big and heavy and draggy, and we can get rid of that, and that will give us quite a big step change in efficiency, and potentially hydrogen propulsion, sorry. Because hydrogen is really light, it comes into its own when you travel a really long distance. And that's being explored by Airbus, although it's a long way off, as I said. The other thing we could do is we could travel in the zero carbon aircraft that fly less far and do multiple hops rather than one big long range flight. So, what policies will help get us there? Currently, the industry says current policies are fine. We've got emissions trading, we've got carbon offset schemes. ICAO has the CORSIA scheme. That's the main policy, covers most aviation. We know, though, this is not going to reduce emissions. Fossil fuel use, carbon emissions are continuing to grow rapidly. We're having a rebound from COVID, and stronger policies are needed if we're going to actually reduce emissions, incentivize the technology I'm talking about, and support fairer access to travel. Um, Carbon offsetting, just something on this. Carbon offsetting is the idea that I can burn emissions somewhere and I'll pay somebody somewhere else, maybe plant a tree, and that will offset the emissions, and we've flown carbon neutral. You might have seen that if you take a flight, you get advertised this. The industry itself, though, admits that that's fundamentally flawed. So the CEO of United Airlines a couple of years ago made the point, if you covered the entire planet in trees, like every single square meter of the planet, that would only absorb about 5 months of humanity's global emissions. Um, you will have, deforested the whole, you will have like removed all of the wildlife, and you will have also like there'll be nowhere to live and nowhere to grow your food. And even then, you've got 5 months, and then there's nowhere else to go. So we need to, the summary really is we need to reduce our emissions, and we need to try and reforest some of the planet. We need to do both of those things. We can't do one to offset the other and neutralize the other thing. Um, so yeah, so we need policies. So who should invest in the transformation? Our industry admits it's going to be very, very expensive. It's going to cost about $200 billion per year to get where we need to get to by 2050. And they lobby governments heavily to pay for this and say we can't pay anything more. We can't, don't introduce taxes on us. Um, but if you think about it, like more than 150 billion a year in subsidies from governments at the moment is completely unaffordable. Um, so transitioning aviation, it's going to have to be a combination of the industry paying more, governments giving some support, but air travelers who are also relatively wealthy and are the ones that are responsible for the emissions will have to pay more as well. But if we have the right approach, we can fund this transition, increase jobs, we can have cleaner environment, and we can have an industry that's more resilient, and that will outweigh the costs, and particularly if we can put those costs onto the people that can most afford it. So I'm going to just take you through this illustration that outlines kind of the key thinking behind safe landing. So as I showed you, there's been a historic growth of air traffic. It's been a kind of exponential. We increase double the number of flights every 15 years. We then had the COVID-19 crash, when there was a sudden reduction in flying, and actually this like massively impacted aviation workers. A lot of them were made redundant. But now we're back on this business as usual growth trajectory, um, where we're keeping the cost really low. We're talking about offsetting, we're kind of distracting from stuff, and we're not pricing aviation as much as it should be. We are really worried that we're going to blow through the budgets that we were talking about a few slides ago. We're going to have massive escalation impacts. We're going to need to restrict flying or make it a lot more expensive very suddenly and severely, and that will cause a climate crash in the industry, where suddenly people can't afford to fly and they don't have access to it. And we've got climate breakdown, so a lot of tourist destinations are going to suffer from wildfires, from sea level rise, from drought, that kind of thing. And that will cause a massive shock, Potentially, we'll still have a livable planet. We can rebuild from that point with zero emissions aircraft. But this bubble and burst scenario is something that we really want to avoid. So what we're saying is maybe there's a safe trajectory where we don't stop flying, but we don't grow we as much as we're planning to. And maybe we can then have a smooth pathway where we moderate how much we fly and then we decarbonize. And after we've done that, we can then start back on the growth again if it's possible at that point. And this is basically the idea behind safe landing. Good news is aviation workers have a really vital role to play in this. So it's not just about restricting things, it's not just about limits, it's about possibilities. There's really exciting new jobs in clean aircraft technology and also getting our infrastructure, our airports ready for these new aircraft, installing chargers, changing, if you think about it, changing the way that our terminals and our gates are laid out to suit these aircraft. It will be a fairer, safer, and cleaner world where aviation supports people and planet. It's also about having workers thinking for themselves, discovering their voice, thinking, well, actually, we have agency to shape the future of our industry, guide the sort of innovation that we work on, and lead the change. And ultimately, it's about having pride in our industry's future. We want to be part of an industry that is having a positive impact on the planet and not a negative one. And we want to be able to say that, we took part in that. We changed direction and we made sure that people, our children can fly in the future and can still enjoy all the tourist destinations we go to today. So yeah, this positive vision of less far, less fast, less frequent, but more accessible, more resilient, smaller aircraft, distributed networks. So we've got more local jobs. And also like the technology that's required, electric motors, batteries, power systems are really applicable in other sectors as well. We want workers to use their expertise and passion to drive the innovation in the industry, not to help just like lobby to delay stuff, and use our voice to push for more progressive policies. And yet ultimately create an industry that we can be proud to continue to work in and rely on when we want to travel. So yeah, if you want to be part of this, come join Safe Landing. I mean, we've got our website here. We're open to workers and students. We're really keen to hear from more students that are just kind of setting out in the industry and considering what career path to go down and what your opinion of the future of air travel is. Um, as I say, like as workers, we are experts in the industry. We're really well placed to give opinions into government about the sort of policies that they should be implementing so that we can innovate as fast as possible. Um, Come take part in some of the assemblies that we run. Simran took part in one in September. We're hoping to do more in the future. We're doing a talk about our London one tomorrow, actually, if you're interested. We also run things called airside chats where we get experts in to talk to our group a little bit like you're doing today. We've got an airside chat with an electric charging company that we're running next Thursday. And then yeah, spread the word. Like keen that you go and talk to your colleagues and friends about this as well, and come along and join. And yeah, just shape this vision with us as well. The idea about safe landing is that we combine all of our different knowledges and skills to come up with something really persuasive, and exciting, and people can feel our passion and can feel how enthusiastic we are about this. So yeah, um, and I've got some other slides about workers' assemblies, but I just I'm aware that I've been talking for a while, so I can stop sharing there and just see if people have got questions first before I go over to
I,
anything else.
I just wanted to say a huge thank you for the presentation. I really enjoyed it, and I'm sure all the participants enjoyed it too. I think my biggest takeaway from this webinar was the various ways to make aviation sustainable. I think most people sort of just think that the only way to go about sustainability is to completely stop flying, but that's not the case. And, we can still continue flying, we can still have our jobs, we can still be part of aviation, but in a way that just makes it more sustainable so that we can still carry on aviation and still carry on flying in the future because one day it will really impact this world and we'll have no choice. If we don't make a move right now, then in the future we'll just have to stop flying because there'll be a lot of emissions. So I really like the work that you do. And thank you so much for ensuring that aviation in the future still exists. And I think more people need to realize how important emissions are and that it really does make an impact. I think the first question I wanted to ask you was,
Go
what
for it.
skills do you think people need to work in the sustainability and aviation sector? And what experiences have made you realize its importance?
So it depends a little bit. It's a good question. It depends a little bit which area of the aviation industry you get into. So obviously it's a bit different from a pilot to an engineer to someone that works in airports. I think generally though, um, if you're interested in sustainability, I think in general, a lot of people kind of just go into a job and they look at what needs to be done to get the day job done, kind of thing. Often, sustainability and environment isn't like often won't be the focus of your job. If you're a pilot, it's like getting passengers from A to B. If you're an engineer like me, it's like making the component that you're working on more efficient or making sure it doesn't break and not really looking at the bigger picture. So I think something I realized is if I work at an aviation company, then I have access to the leaders in that company and I can ask them questions. And and I think that yeah, so part of it is just starting with the curiosity to ask questions and also thinking, actually as part of this industry, I have quite a lot of leverage and I have quite a lot of opportunity to talk to people and get answers on stuff and discuss topics that wouldn't be available to people that are outside of the industry. If you're an environmental campaigner and you're at Greenpeace, you'd probably love to be able to talk to the CEO of British Airways or EasyJet. But if you work at those companies, like you literally have their phone number and email. And that's what I did when I was at Rolls-Royce, is I actually just emailed the CEO and said, like, I want to have a meeting about
Wow.
this. I want to ask questions about the strategy, or the chief technology officer and that kind of thing. So actually just being like, I have a part to play in this, and I can connect with other people that are interested in this and collaborate on it. I think that's the most important part. And that doesn't mean that you need to have a job that's specifically like working on an electric aircraft to do that. You could be like a mechanic for a jet engine, but still like say, well, actually, I'm gonna like ask some questions of my company, um, and and have that conversation. So part of it's that. I mean, if you do want to get into specific companies and which ones are more
Mhm.
promising than others, I'm very happy to like share my thoughts on that. Like as I said, I'm really interested in hybrid electric aircraft companies. There's um a couple in the Netherlands, like Viridian's the one that I showed you that was battery electric, fully electric. They're in Germany. There's Elysian that's in Netherlands, um, or Aero or in France. In the UK, we've got Zero Avia, but we've also got some like battery and electric motor manufacturers and that kind of thing. And then generally in the bigger companies, there's specific parts, departments that work on more sustainable stuff. But yeah, generally, if you ask questions, that's a really good starting point. And it's always good, if you have an interview with a company to ask them the question during the interview. And I think, firstly, that will show that you're interested, but it'll be quite interesting what their response is as well.
Yeah.
So there's always opportunities to do that. Yeah.
Thank you so much. I think now we'll move on to the questions that the participants have asked. So I'll start with the first one that Ashish asked. Ashish, would you like to unmute yourself and ask this, or should I just speak for you?
Go for it, Ashish.
Hi,
Or
can you hear me?
yeah, I
Yeah.
can hear you. Yeah.
Yeah. Yeah, cool. So I was just wondering, Finley, what your view on algal biomass, SAF, and what the future looks like for that, because it can be cultivated from like non-arable land. And obviously it would act as a drop-in fuel, which means that obviously we wouldn't have to replace as much infrastructure compared to like electric aviation, for example.
Yeah, so it would be for other people's awareness, like algae is, yeah, often it's the kind of like it's almost like green sludge that floats in the ocean, and it is like an organism that thrives off sunlight and nutrients in the water. And it's like, well, if it can just grow like that, then maybe we can grow it and harvest it and use it for energy, and it creates oil, and we could use that oil to create fuel. Um, the thing is, if you go and look into it, we've been trying to do that for the past 15 years, and none of the companies have actually managed to commercialize it. To the extent it's not really being looked at as a serious option at the moment. So generally, with technology, it's good to be skeptical about it. Often when there's startups and companies doing something, they will overpromise, overpredict, and try and get funding. It's not that we should rule it out. So it's completely possible we might be able to create a fuel from algae, but also we should have a safety first. Like in aviation, we have like safety is our number one priority, and we wouldn't take off in an aircraft if we thought there was a chance that it was going to fail mid-flight. And I think we should take the same approach with this. So obviously, if someone can show it works, then brilliant, and it probably we should support like research and development into it. Unfortunately, so far, it's not proven to be effective, and part of the problem is um, you actually end up needing to. It's quite complicated to do because you need to set it up in a way that it gets solar energy and that it doesn't kill itself, and it ends up you need quite a lot of energy to do that, and it's quite intensive to get it out. So there's like practicalities with actually doing it that have meant that no one can actually commercialize it and scale it up beyond like lab scale. So hopefully in the future we can do something like that, but we should probably, until we've proven it, we shouldn't rely on it, I think is the answer.
Yeah, that's perfect. Thank you so much.
No worries.
Thank
Is it
you.
Daniel next?
Yeah. Daniel, would you like to unmute yourself?
Hello.
Hi.
My question was, you said that it would be cheaper with like planes overall, right? But would it be more expensive to fly them to begin with because of the development cost as well as the cost of infrastructure surrounding them?
Yeah, so um it won't be cheap like cheaper than a bus or something, but it could well be less expensive than flying today. Although you won't be able to go as far and as fast, you'll be more limited. It will mean that, I mean, basically you've got batteries and electric motors and you can charge the batteries and it's really efficient and it's really simple. So a jet engine is really complicated and it's got a lot of maintenance requirements. An electric motor and a battery are really simple. So you'll start to see us really benefiting from electric cars getting scaled up, batteries improving, the cost coming down, the performance going up. Um, so it's hard to say like exactly how much it's going to be. Um, Really, because they're smaller aircraft, a bigger cost comes like the airport landing fee, and actually you have to pay a pilot, and you only have 9 passengers. So like the staff costs become more expensive, or like actually the more expensive part rather than the aircraft. Um, but the good thing about that is more jobs. And also is potentially like kind of have a different maybe pilot's license for that type of flight. Also potentially autonomous as well to help with that cost. But yeah, the other thing is there is a company called Electra Aero that are doing it's not vertical takeoff, but it's ultra short takeoff because they have a blown wing. And it basically means they can land on an area smaller than a football pitch. And actually, if you go on their website, they take off in like less than 100 meters, um, take off like almost immediately, and they can land on like literally on like a school playing field, completely possible. So you might start to see these actually really small airports that look really different. And you also like go to the airport and like within maybe 15 minutes you can get on the aircraft and you can go, and it's a lot faster. You don't have to go to a large airport, go through all the security, the baggage, like going through a big shopping mall kind of thing. So you might find they call it like more like direct aviation. So actually like it, because the airport's more local, because you go more directly where you're going, um, it could be faster as well. So yeah, these companies are showing that it could be like cheaper than getting an Uber there to do this. I would say it's still going to be like relatively expensive, but not like as expensive as flying today. Apart from you're not going to be able to go as far and you're going to be in a smaller aircraft, and that's a bit of a different experience um, than flying in a really large aircraft. So yeah, I'm quite optimistic the price won't be too high and it will actually make air travel more accessible to some people, even though it's likely to be really expensive to fly long haul in the future because you can't get away from the using jet fuel and having to use alternative jet fuel that's um, multiple times more expensive than fossil fuel.
Thank you.
No worries.
We have one last question, and that's from Amia, if I'm saying that correctly. Would you like to unmute yourself? If not, I can say it out.
Yeah, totally. My question was, what does the impact of business aviation have on carbon emissions within the...
Yeah. So you think you cut off there, but I'm reading your question. So yeah, business aviation, which is also private jets, right? And yeah, so the carbon emissions, I mean, the carbon emissions are a relatively small part of overall aviation, but per flight, per passenger, they're really high. Um, so I think there's a lot more we could do to regulate them and to make them pay a lot more. Um, Regulate, I think we should apply carbon budgets to private jet airports that are a lot more severe than conventional airports, because private jets are, they tend to be smaller, um, and so they're actually quite well suited to going to zero carbon aircraft, and also the customers, because if you think about electric cars 10 years ago were really expensive and they're rapidly coming down in cost. Tesla initially started selling to really wealthy people, people that could pay 100,000 for a car, and now we're getting towards like 30,000, 20,000 pounds. We're going to see the same thing, like a cost curve reduction with electric aircraft. So it makes sense the wealthiest in society that pollute the most um, pay the earlier higher price so they can bring it down in price for everyone else. So yeah, we're really keen that private jets are regulated and they're taxed more to raise revenue for the innovation. I think that, yeah, and it's something that has genuine like popular support because most people don't fly private jets. There's growing inequality in society. The wealthier are getting wealthier. Everyone else is not doing as well. So it makes sense to target the people with the biggest pockets and the broadest shoulders to pay for it. Um, that's not to say if you got rid of all private jets today, it might cause like, 2% reduction in emissions because it's not the biggest thing. There isn't that many billionaires. Um, but from a fairness point of view, it's really important those people are paying more than everyone else, and we should be utilizing that to accelerate zero carbon flight that's going to benefit everybody else. Um, so yeah, hopefully that answers the question. I did just see, so Ashish also asked if we can possible to do a talk at my school. The best thing to do is just to send us an email. I'll put my, just info safelanding.org. It'll just depend if when you'd like to do it and where you are. And we maybe just have a look at our schedule and see if we can, because we like to do these talks every so often, and can make time for that. But just see what your timescales are and what our availability is. We're very happy to consider that, though.
I think that's all the questions answered. Thank you so much for hosting and for presenting. I learned so much, and I'm pretty sure all the participants learned so much too. And yeah, I look forward to more webinars and learning more about safe landing. A huge thank you for everyone attending as well.
But thank you so much, Finlay, and thank you guys. I know I stayed in the background for today, but really thoroughly enjoyed it. And Finlay, thank you for sharing such, I would say, controversial opinions. I'm sure they're not the most popular both in the aviation community, but they're very much important to discuss. And certainly when it comes to young people and raising the awareness of some of the challenges that we're facing as an industry, and raising some of the questions around how things are done and should they be done the same way going forward. I think that's very important. So thank you so much to you, and thank you all. Thank you, Simran, for hosting. It was wonderful to see everybody here. Please stay in touch. We've got loads of events and collaborations happening, and I'm sure, Finlay, this isn't the last time we are going to see you as well. But thank you so much all. Enjoy the rest of your evening, and we will see you soon. Thank you. Take care.
Thanks for having me.
Thank you.
Thank you.